our students, let us proceed, and at this time we're going to finish up today's lesson by looking the examples on questions concerning about what you have learned today. Now let us look direct to example 1. The example 1 is saying, what is the fundamental frequency of a guitar string whose tension is adjusted to give a wave speed of 143 meter per second if the length of the string free to vibrate is 0.65. Therefore, we have given here, been given the following. What have we given? We've been given the V speed 143 meter per second, but also have been given length of the string 0.65 meter. We've been required to calculate fundamental frequency. Solution: how can we find fundamental frequency of vibrating string? From fundamental frequency equals to V of 2L. I think you remember how did we get this fundamental frequency. Therefore, we substitute the data. What is V? 143. What 2 is constant times L. L is 0.65 meter. Now, if your calculator is good, you'll find fundamental frequency equals to 110 Hz. Therefore, fundamental frequency is equal to 110 Hz. This is the fundamental frequency. Let us go to example 2. Let's go to example 2. Example 2 is saying a wire of length 140 centimeter and the mass 0.52 times 10 power negative 3 kilogram is stretched by means of a load of 16 kilogram. Calculate the frequency of the fundamental. Take G equal that one. Therefore, we have been given the following. Example 2, have been given a wire of length L equals to 140 centimeter. This is like to say we have how many meter divided by 100, you get 1.4 meter. And the mass M equals to 0.52 times 10 power negative 3 kilogram. Load M capital is 16 kilogram. Calculate the frequency of the fundamental. F naught is equal to solution. Here is the solution. How can we find fundamental frequency? Is from F naught equals to V of 2L. But bad enough, we don't have V, but we know how can we calculate V. Therefore, this is equal to say 1 of 2L under root of tension L over M. Bad enough also, we don't have tension, but we know how we can find tension. Tension is force. Force equal to mass times G. Therefore, this is to say fundamental frequency will be equals to 1 of 2L under root of, we don't have tension, but we have mass which will bring about tension, mass of the rod. Therefore, we're going to use M capital. Tension is M capital G L over M. Therefore, this is to say 1 of 2L, what is L? 1.4, under root of M capital 16, G is 9.8, L is 1.4. You divide by M small. M small is 0.52 times 10 power negative 3. Now, if your calculator is correct, you'll find that the fundamental frequency is equal to 232.05 Hz. This is the fundamental frequency for example 2. Now let us look example 3. Let us look the example 3, which is the last example. Example 3, let me lab here. Example 3 is saying a string has a length of 75 and a mass of 8.2 gram. The tension in the string is 18. Calculate the fundamental frequency, third harmonic frequency, and first overturn. Let us go direct to the data given. The data given is a string has length, therefore we have length of the string 75 centimeter. We change it to meter, we get 0.75 meter. But another thing we have is mass, m, 8.2 gram. This is 8.2 times 10 power negative 3 kilogram. Another thing we have is tension. This is 18 Newton. Required to calculate the following. Fundamental frequency required 1 have been asked to calculate 1 F naught. Solution on calculating F naught. I think you know what is F naught. For a vibrating string 2L, this is like V. We don't have direct, but we know how we get V. This is the same as 1 of 2L tension L over M. Therefore, this is like to say 1 of 2 L is 0.75, under root of tension is 18, L is 0.75 over M, 8.2 times 10 power negative 3. Therefore, if your calculator is correct, you'll find that fundamental frequency F naught is 27.05 Hz. 27.05 Hz. After that one, you have been also asked to calculate, this was fundamental, to calculate third harmonic frequency, which is F3. F3 equals to 3 of 2L under root of tension L M. This is F3. Now it is the matter of substitution. This is equal to 3 of 2. L is the 0.75 under root of tension is 18. L is 0.75 over M, 8.2 times 10 power negative 3. If your calculator is good enough, you get that the F third harmonic is 81.15 Hz. This is the third harmonic frequency. But also have alternative of calculating third harmonic. Alternative, you recall from F3 is 3 times F naught. I think you remember this. Therefore, what is F naught? F naught is 27.05. 3 times 27.05 is the same as 81.15 Hz. Therefore, if you're going to use the formula or the alternative, you're going to get the same answer. The last one is the first overturn. You've been asked to calculate the first overturn frequency. You've been asked to calculate first overturn frequency, which is F1 bar equals to, I think the formula is known. For us to get F1 bar, the formula is 1 of L under root of tension L of M. Now this is like to say 1 of L, which is equal to 1 of 0.75 multiplied by T L, tension is 18, L is 0.75, M is 8.2 times 10 power negative 3. Therefore, the frequency of the first overturn is 54.10 Hz. This is the first overturn frequency. But also we can go alternative. Alternative we'd call first overturn F1 bar is the same as N plus 1 F naught. Therefore, N is 1 plus 1 times F naught. Therefore, the first overturn is the same as 2 F naught, which is to say 2 times fundamental frequency, where the fundamental frequency obtained was 27.05. Now, after substitution, you'll find that the answer is 54.10 Hz. Therefore, you can use the alternative or the formula to get the first overturn. I hope you have understood. See you in the next lesson. Bye.